This video is about the question of why do we have a complex conjugate in the expression for correlation. On the screen, you can see the expression for correlation between two signals. One of them is ZT, the other one is GT. So GT has been delayed in this case, so that it overlaps with the signal ZT. So this delay is in order to have a time overlap between the two signals. And then we can also write the same expression by advancing one of the signals. So for example, in this case, we have advanced ZT by the same amount of tau, so that both of these signals, ZT and GT, overlap. Now the question is, why do we have a complex conjugate applied on one of the signals? So the answer lies in the fact that we want to get maximum out of this convolution relation. So let's say we can explain it in a mathematical form. Let's say we have ZT, a complex number, and it can be written as A plus JB. Similarly, let's say we have GT as C plus JD. Now, if we take the product of these two as we have it in the expression for the correlation, the product becomes equal to AC plus JAD, and then plus JBC, and minus, or let's say J square BD. So because of this J square, we will have a minus here. So the real component of this product, ZT, GT, the real component is equal to AC minus BD. So now you can see, in this case, the real component would be having, for example, some value, which would be small because of this subtraction. So the product of AC is being subtracted by the product of BD. So this term would have some value of X. Now, if we use complex conjugate of one of the signals, let's say we use GT conjugate, then the same GT becomes C minus JD. So it's C minus JD. Now, if we look at the product of these two, the real term in the product of XT and G conjugate T is now equal to AC plus BD. So in this case, you can see the real term is larger than the previous case when we had not taken the conjugate. So AC, it's larger than AC minus BD. So in order to have, in summary, in order to have maximum value of the real component of this conjugate, of this correlation formula, we use a complex conjugate.